Hey everyone, Trey here. Happy New Year to all of you out there. We've got another severe threat for the southeast today. Enhanced risk for much of Tennessee into northern Mississippi and Alabama, surrounded by a slight risk that extends all the way up to about, Charleston, West Virginia, down toward even far northeast Texas. So we've got some severe weather to talk about to kick off this new year. 10% hash tornado area coinciding with the enhanced risk, a damaging wind threat, as well as a hail threat for the storms today. It's kind of an interesting setup, kind of a conditional setup. So we will take a look at why this setup might be conditional, at least for strong tornadoes. We'll take a look at some of the possible outcomes here, but let's get started. Let's take a look at our satellite imagery, and you can see big old trough here in the water vapor imagery, kind of ejecting out into the plains and up into the Midwest, this kind of fire hose of moisture up in here with some storms ongoing. We've got quite a bit of convection ongoing right now. If we take a look at our radar, big old band of storms kind of along the frontal zone. If we look at our surface data here, let me refresh it. So this is about 5 minutes ago, our surface map, and you can see the wind shift here. Kind of northerly winds out across Oklahoma, across the Red River area, up into southwest Missouri. So we've kind of got a baroclinic zone or frontal zone here, somewhere in this region, roughly, going through about central Arkansas up into western Tennessee, western Kentucky. You can see the winds pretty clearly shift from southerly here in western Tennessee to northerly here as you go toward the Kentucky-Tennessee border. So some sort of baroclinic zone there, and maybe something else in here, but that's not going to be much to worry about. This one is kind of our current sort of baroclinic zone that these storms have fired on this morning and overnight. We had some severe warnings here overnight from this kind of band, and it does extend all the way back into Arkansas and down into southeast Oklahoma. You can see this looks very cold, kind of in the cold air up here. You can see temperatures into the 20s back here in southeast Kansas, the 30s across Oklahoma. Still kind of cool back here, but this is nothing to worry about as far as a severe threat goes. This is elevated to the north of the front. You can see the outflows extended out in front of it already, but a band of convection that is going to serve a couple of purposes for today. And number one, that's going to kind of reinforce this baroclinic zone throughout the day. When you have a lot of convection along into the north of a frontal boundary, usually if you don't have any, it tries to advance to the north. It tries to bring that sort of warm, moist air from the Gulf to the north, and it will keep going to the north if it's not reinforced by convection. But in this case, when you've got all this convection to the north of this boundary, it's the outflow from this convection is going to either keep it in place, given southerly winds to the south of the boundary, and northerly winds, kind of northwesterly winds from the outflow, will kind of keep this in place, or it may even push this boundary a little bit to the east and kind of allow it to surge throughout the day, which is not something we like to see as a storm chaser, because that will kind of allow the front to move and maybe undercut any convection that forms along or out ahead of it. So that's that. Let's go ahead and take a look at our broad scale pattern. You can kind of see where this frontal zone is, this kind of pressure tongue here. And we've got maybe some weak sort of surface low centers along that boundary, but we're not going to see anything as far as a deep cyclogenesis here near this boundary, near the warm sector today. If you take a look at our 500 millibar map, this is something we don't often see across a severe weather event for the southeast, and that is really a sort of de-amplified pattern here. Not very much in the way of a kind of shortwave trough here to kick things going, at least a well-defined shortwave trough. We've got our kind of major sort of trough back here across the western half of the U.S. That is actually not going to be so much in play. It's not really going to eject quickly enough to get the exit region to coincide with the warm sector today. It's going to have to rely on these little kinks in the ISO heights here, these little sort of short waves that will pass through the warm sector along the frontal zone and kick convection off in these areas. If we look to 700 millibars, take a look and see if we can see any short waves here. We got maybe one in there that's centered across the kind of Illinois-Indiana border at this point. Maybe one back in here across western Arkansas that might be allowing this convection to sustain itself. And if we go down to 850 millibars, we've got a pretty decent low-level jet in place across a broad swath here. So from all the way from West Texas across the Gulf Coast states into the Atlantic seaboard here. A 40 to 50 knot low-level jet here across the threat area, and that should stay in place throughout the day. We're not going to have significant cyclogenesis, however, so um, we're not going to see a incredible mass response, what we call it, kind of this response of continued warm moist air to the east and southeast of a developing surface low. We're just going to have this strong kind of low-level jet in place throughout the day. We will get some semblance, I think, of cyclogenesis kind of along the baroclinic zone, along the frontal zone here. And it might be sort of a frontal wave, but it's not going to be your typical kind of development from a sort of Lee cyclogenesis case in the plains or something like that. But nonetheless, we will have southerly flow across the region throughout the day, pumping that moisture northward. You can see dew points in the 70s along the Gulf Coast here into the mid 60s the farther north you go into Mississippi and Alabama. So there will be a warm, moist air mass in place, at least for this time of year. So the thermodynamics, at least at the surface, are looking pretty good. But let's take a look at some soundings here. And so this is a Jackson, Mississippi sounding from 12Z this morning, so 6 a.m. Central Standard Time. And you'll notice we've got already some weak sort of weak instability in place. Photographs very favorable already. It tells you there's lots of warm advection ongoing with these low-level curved photographs. So that's favorable for stronger convection later this afternoon, particularly supercells. But this may be the bugaboo. This may be the fly in the ointment with the setup today, and that's this big old dry/warm nose here at 700 millibars. The fact that we don't have a real well-defined shortwave, I think, is going to be the hindrance to this event. This is kind of what it's going to look like later on this afternoon as we go into the prime time for this event. We're going to have kind of mainly zonal flow, a little bit of a southerly component there, but more or less zonal flow, and we're not going to see this shortwave eject or any sort of well-defined shortwave eject into this region. We do see a little bit of a sort of shortwave there across Oklahoma and Texas and Kansas. That may eject, but that's going to be off to kind of the north and northeast of the warm sector. So we're only going to get a very glancing blow across the warm sector, and you can see that we've kind of almost got ridging across the warm sector here as well. So the prospect of open warm sector convection, which would have the greatest potential for significant tornadoes from discrete supercells, is very, very much in question today. Given this warm nose, given that we won't have a whole lot of height falls across the warm sector, we won't have a big old shortwave digging down where we have height falls in the exit region to lift that cap up and cool it and moisten it. I don't know if we're going to get a lot of warm sector convection today. This is not a hugely strong cap. The convective temperature 83 degrees here. So this is kind of breakable. I do think it is breakable, but what are we going to break it with? We're not going to get a big old trough. We're not going to get a lot of height falls to break this cap. So this may be a little bit stubborn today. We may not see a whole lot of robust convection in the warm sector. We may see, given the southerly flow, given the sort of warm moist advection here that will continue throughout the day, we may get a lot of kind of little convection to fire across the warm sector. But I question whether or not this is going to be the case here in kind of at least the western half of the warm sector here. This is the Shreveport sounding, much of the same, kind of a big old warm nose here between 850 and 700 millibars. But as you can see, photographs very favorable and should stay favorable given a pretty potent low-level jet in place throughout the day. I would expect these photographs to remain very favorable for tornadoes. Perhaps some strong, if any, convection can fire in the warm sector. Now let's take a look farther east here, and you'll notice here at Birmingham and at Nashville that we are quite uncapped. We do not see as much of that warm nose at 700 millibars. Very deep moist layer here at Nashville. Same thing here at Birmingham. But you can see we've got lots of Cape here confined to the lowest levels, kind of below 500 millibars there. And you will see we should have a 0 to 3 Cape value that's favorable. Yep, 83 joules per kilogram. So given the fact we should see some warming here across this region throughout the day, we look at our satellite map real quick here. We should have a fairly clear, at least some breaks in the clouds here in the warm sector. You can see if we zoom in to our southeast sector here, you can see kind of those cloud streets. You can see that warm moist advection ongoing throughout the Gulf Coast states here right now. There should be plenty of breaks in the clouds across this region to foster an increase in instability throughout the day. So here, at least farther east, we could see a better chance for isolated convection if this stays the case. We don't see as much of a cap here, at least across the eastern portion of the warm sector. Now with northern extent, I do have some concern that this convection here along the frontal zone here will start to shift east throughout the day and kind of pinch the warm sector with northern extent here across Tennessee and even into far northern Mississippi here. So I do think the warm sector will shrink throughout the day, but if we can get something going here across northern Alabama, maybe far northeast Mississippi, where the cap is not as strong, I think we'll have a better chance of seeing a discrete supercell threat with tornadoes here somewhere across this region throughout the day. So we'll have to keep an eye on that. Interesting development there. So farther west looks like the cap may be a little bit more stubborn. We're not going to need the cap to erode as much farther east as we're already kind of uncapped here across at least the eastern portion of the enhanced risk area. So we do have a strong supercell wind profile in place. That is no question. You can see that here from the morning soundings, and that should only maintain itself throughout the day, given the strong low-level jet forecast to strengthen a little bit even throughout the day here. So wind shear in place. We do have the moisture in place. The thermodynamics are somewhat there. We'll have to monitor this capping inversion throughout the day. But my question is forcing. Are we going to get enough forcing to get storms to go? If the shortwave continues to fire off, eject to the northeast, I think we'll see a reinforcement and reinvigoration of this convection along the frontal zone. Therefore, we'll get very messy modes here along the front this afternoon, and will be more of a damaging wind threat here, perhaps with an embedded tornado or two. But we'll have to monitor this discrete storm development out here in the warm sector. If there's any sort of confluence lines, little sort of convergence zones out here in the warm sector, that will help. And some of the models have been hinting at that, but we'll have to monitor that. That's kind of it's not really something we can see on the models with this kind of coarse resolution compared to what we would have to make out these kind of convergence zones here in the warm sector. So we'll have to monitor that throughout the day. This is going to be some model data here. We'll take a look at our NAM run from this morning, 12Z. You can see pretty good depiction here of the overall 500 millibar pattern. Kind of some ridging here across the eastern half of the U.S. Our big trough digging down into the southwest. A little shortwave out in here. So you can see that we're going to kind of maintain this sort of zonal flow out here across much of the warm sector and across the sort of frontal zone area. You can see this shortwave kind of continues to de-amplify a little bit as it ejects off into the Midwest. So really, forcing is going to be in question today. I think we will get forcing along that frontal zone. I think that frontal zone will be needed. So I think the bulk of the convection we're going to see today is along that frontal zone, kind of what we've already been seeing, kind of a reinvigoration of this convection along the frontal zone here. So I think the mode, given that the shear vectors here, we'll just look at those real quick here. The shear vectors are going to be very much parallel to that frontal zone that may even be surging a little bit to the southeast. You can see the wind barbs here oriented along that frontal zone. I think we will see a very, very messy mode here along this front. So more of a damaging wind threat along the front here, um, with perhaps an embedded tornado or two. But out in the warm sector, it does favor discrete supercell development just by nature along these confluent zones. So we'll have to monitor that throughout the day. Let's go back to 700 millibars, see if we can see any more well-defined short waves here. And maybe something in there, but it's kind of hard to tell. Yeah, there's just not much in the way of forcing today. Not a lot of height falls to lift that capping inversion across Mississippi, western Tennessee. But you can see we will have a strong low-level jet in place throughout the day. So 40 to 50 knot low-level jet here across the region throughout the day, which is definitely favorable to keep those photographs large and looping throughout the day, at least in the low levels. So this is our surface pattern. Let me actually back out again to the Kona so you can kind of see what the entire pattern here. There's our frontal zone, lots of cold air behind it. So whenever you see lots of cold air behind it, a very, well-defined frontal zone, oftentimes that cold air wins out and you get that front to surge a little bit to the southeast. And that may be the case today, given we already have convection ongoing along, just to the north of it and along it. So that may push the front a little bit south throughout the day, and the cold air may win out here, especially with western extent across the region here. And as we go to the overnight hours, you see that front really start to surge, that warm sector really start to get pinched, and what should be a sort of band of convection, messy convection along that front may have a severe threat there. But if we zoom in here, let's zoom into our dew point. You can see we have a very moist and unstable, moist air mass here at the surface. And you can see that front really start to surge from behind here. So here's our frontal zone. Let's take some soundings along at 21Z. So we'll go kind of out in sort of west central Mississippi here. We'll take one kind of near Tupelo, maybe one out here toward between Huntsville and Birmingham, and then one up sort of in Tennessee here out ahead of the front. So you'll notice here we have got large looping photographs. So this is west central Mississippi. We do see some evidence of that cap eroding, but again, like we saw the other day, tall, skinny cape here, which does favor sort of wet rear flank downdrafts, less robust convection, less robust updrafts. So that remains to be seen. Again, whether we can get, if this is the case here on the NAM, where we get this sort of erosion of the cap, I do think we will have the potential for discrete supercell development in the warm sector, but we'll have to watch. That cap may be pesky given the lack of height falls here. And then with northern extent, we do see a decrease in instability, but a maintenance of these large looping photographs here. So the kinematics, the wind profiles in place, will no doubt favor supercell tornadoes. The question is, will we get discrete supercells along or in the open warm sector? We'll have to monitor the surface map for any confluent zones throughout the day. But if we do have that band of storms continue along that frontal zone, no doubt we'll have an embedded tornado threat, QLCS tornado threat, given these large looping photographs here. Very strong low-level jet. You can see the 1 kilometer winds approaching 50 knots here. So that's what's maintaining these kind of large looping photographs throughout the region, throughout the day. So let's go ahead and see if we can maybe make out anything here in the warm sector as far as confluence bands, maybe prefrontal sort of troughs here. There may be some semblance of one here across Alabama. But very hard to tell at this resolution whether or not we're going to see any any of those confluence bands throughout the day. That's going to kind of be a wait and see sort of thing. So let's finally look at some cams here just for fun. This is the 12Z HRRR. You can see just that mess of convection along the frontal zone. And as we go throughout the day, the HRRR does have quite a preponderance of warm sector convection. Now, how robust is it? We're not seeing a lot of updraft helicity tracks here with these, so The herd does often have an issue, though, with these kind of prefrontal beans, if you will. They often will not show a strong helicity track signal. But the thing to note here, I think the main thing to note here is that the herd does have quite a bit of convection in the warm sector. That would have the potential to be supercells with tornadoes, perhaps some strong. And then you can see along the front there, we just have this kind of broken band, a messier broken band of storms that surges east throughout the afternoon and evening. The WRF ARW here, much of the same, that sort of band of convection along the frontal zone, very messy. And it does kind of show a few beans forming out ahead of the front here in Tennessee. These would be the ones to watch. I think the instability will be less up here, but the kinematics will be a little bit stronger given this is kind of closer to the main forcing, closer to that shortwave trough that's ejecting into the Midwest. So I think up here, sort of northern Alabama, southern Tennessee, maybe into far northeast Mississippi will be the best shot for supercells with strong tornadoes today, just because it's a little bit closer to the forcing. But given the proximity to the frontal zone convection, how long that lasts is up in the air. We do see, though, the ARW here does have some convection in the open warm sector. We'll have to watch that. Doesn't really develop it all that much, which likely says something about the forcing and about the degree of capping that might persist across the warm sector here, across Mississippi especially. But we'll have to watch that throughout the day. And then finally, NSSL WRF for one last cam here. You can see very messy along the front. We do kind of see some evidence of embedded supercells here along that front, but this model definitely does not have as much warm sector, at least robust warm sector convection. So all in all, there is a very conditional threat of supercells with strong tornadoes here across northern Mississippi, northern Alabama, central Tennessee especially. I think the bulk of the convection will be along the front here, kind of a reinvigoration of what we're seeing now. That will move off to the east and southeast throughout the day with a damaging wind threat mostly, perhaps an embedded tornado or two, given the large looping photographs, but we'll have to watch. This is going to be the area to watch here, probably from Nashville all the way down through kind of the I-55 corridor there in Mississippi over to Birmingham and Chattanooga. I think this will be the main region to watch for discrete supercell development throughout the day today. And if we can get that Cat 2 erode, as we were seeing here, if we can get any confluent zones in the warm sector, I think we will have a shot at seeing discrete supercell convection. But again, very much up in the air today, given the cap in place, given the lack of forcing across the warm sector. We'll have to watch that for sure, though, throughout the day. That's all I've got for now. Thanks for watching, and we will see you in the next video.